What we are going to do now, for time being, we are going to move from long run to short run. Okay? Cost curves in short run. And how short run is different from long run?
So at least one of the variable does not change.
One of the inputs, one of the inputs cannot be varied. And so far we have been talking about that capital is that input which we cannot vary in the short run, but just keep in mind it can be any input. So what we can, again we can start with the total cost. Remember this total cost, it can be divided into two components. One is fixed cost and second is variable cost. What we have learned in the long run, that total cost is a function of Q. Okay? Anyway, if you look at this graph, what we have here is K and L. Even if we use different combination, it will depend, total cost will depend on the K, amount of capital used, amount of labor used, and of course amount of capital and labor would also determine the quantity produced. So total cost is a function of Q. How about the fixed cost? By name it should be clear that the fixed cost is the component of cost that does not vary with the output. So let us denote it by FC. Okay. In our case we can say that if capital is fixed at 5, then fixed cost is the cost of having these 5 units of capital. But even further, I am not parsing it that much, but you can think of that fixed cost can be of two type. Okay. One is, you can say one component is what, I do not know what name to give, just think about it, that one component of fixed cost is that you incur it even if you do not produce anything. Okay. Like for example, you have decided to start a firm to produce, let us say, pen, and you have already hired, rented a building, you have already hired some machinery. Okay. You are not producing anything, you are not operating anything because you have not yet hired the workers, but still you have to pay for the rent of that building and the rent for that capital. Okay. So even if you are not producing anything, you are incurring that cost. So that is one kind of fixed cost. Second fixed cost can be that it depends on only your decision to produce and no production. If you do not produce anything, you do not incur any cost, but if you decide to produce even 1 unit, then you incur that cost. But why I am keeping it in the fixed cost? Because that cost would not change with the level of production. For an example, let us say that government has this regulation that if you produce, you will have to get your output audited or your cost audited. So it does not matter whether you produce, and cost of audit is, let us say, independent of your output. It is about, if you hire an auditor, you have to pay, does not matter whether you produce 5 units or 10 units. So that is a different, if you do not produce anything, you do not have to hire that auditor. So that cannot be a cost to you, but if you, even if you produce just 1 unit, you will have to hire that auditor. So it is a different kind of fixed cost, but for theoretical purpose, so for we would not distinguish between these two different kind of fixed cost. Even the example that I gave you of the building, we can say that again, if we have a building and building can accommodate, let us say, production up to 1000 units, but if you go from 1000 to 1001 you will have to rent another building. So, now it becomes here dependent on the output, but here we will keep it if as long as we are producing in this zone 0 to 1000, of course, for this particular example, and for theoretically as long as we are in the zone we will keep the cost for that building in the fixed cost. Is it clear? And what is variable cost?
Sir, the cost of labor.
In our example the cost of labor, because cost of labor we can change, cost of labor would change with the labor that we would change with different level of production. So, in other word, variable cost is the component of total cost that varies with the output. So, I can say Vc is a function of Q. So, total cost that we have here is again a function of Q, which has two components, a component that depends on Q and the second component that is independent of Q. So, we can try to draw it here. This is very simple. Let us say here we have cost, here we have output, and this is fixed cost. By definition it does not change with the output, fine. And here we have, let us say, variable cost. Typically variable cost will start at the origin, because it varies with the output. No output, no variable cost, okay. And by adding these two what we can get is total cost. So, from variable cost how can we get total cost? It is just parallel shift, and how much is the shift equal to?
The fixed cost.
The fixed cost. This is the amount of fixed cost, here it gets added, fine.
Yes, sir.
So, just let me just write it here. What we have done so far is that we have taken Q is a function of K and L, and what we have said in the short run K is equal to K naught. So, what fixed cost we have? R multiplied by K naught. This is the fixed cost. And how much is the variable cost?
WL.
WL, because remember this is fixed, this is not fixed. So, what we get is total cost as fine.
Yes, sir.
Okay. What we can do, we have earlier defined the average cost, that is basically average total cost. We can define also average using the concept of average. What we can define is average fixed cost and average variable cost. In short, average fixed cost is AFC, and it is nothing but fixed cost divided by total quantity.
Goods.
Can you draw this? How would it look like?
Sir, it would shrink to lower level. The straight
So,
line.
starting from really infinity, because when you have almost 0, like let us move in the direction of 0, direction towards 0, then what do we get? Really very high fixed cost on average, okay. And we keep on producing more and more, the fixed cost gets distributed over large amount of output. So, average fixed cost starts decreasing as the output increases, and eventually it becomes equal to 0, okay. Average fixed cost and here output. More technical would be to say that asymptotically it becomes equal to 0, because in reality it never is equal to 0. And how about average variable cost? We cannot say with certainty how would it look like, but let us say this particular case that we have taken, and Q is equal to, let us say K0 is equal to 5, and q is equal to 1 by 5 k L. So, in the short run what we are getting 1 by 5 multiplied by 5 multiplied by L. So, q is equal to L. So, in that case variable cost is simply variable cost and q output is simply a line passing through origin. So, in this case average variable cost is going to be fixed. So, this is what I want to emphasize, that do not get confused. Average fixed cost is decreasing with output, while average variable cost is fixed with the output, and this is a common mistake that people make.
But this is for only the given case.
Even for the given case, but what we can have, what I am saying, there is a possibility that average variable cost is fixed. We may get, let me use a different color, we may have something like this, okay? Or more appropriately, if you think about it, remember when we were talking about production function, what did we say? That output increases in the beginning at the fast rate. So, in that case if it decreases at the fast rate, it means average variable cost is decreasing, and then rate of increase becomes
More.
It starts decreasing of outputs, the rate of increase in output starts decreasing, and eventually it becomes flatter and flatter. So, here we are getting the opposite result, and that we will see immediately.
So, sir, in this graph, if L is varying, we got the final Q as L. If you
so this is, just let me erase this. So, this is the case.
So, but if L is varying, then this won't be a straight line.
It won't be a straight line. It would be something different. That is what I am saying. So, one case would be that it would be something like this.
Okay, sir.
Okay, and there is a reason that I am picking this one. Remember when we were talking about.
So, but if labor is fixed, how will it be a variable cost? It won't come into the
labor
category.
is not fixed.
So, like the calculation you did just before the graph.
What we have learned here in this graph, just look at this graph again. What is happening? Rate of increase in, again we do not have the same production function as q is equal to L. It is a different production function. The functional form is not given. What is happening here? L is increasing, q is increasing. Here rate of increase is increasing with L, but eventually rate of increase in q starts decreasing. So, what we have learned, it means what is happening here, what we have learned just in the context of return to scale. In this zone what we are getting is basically increasing return to scale, and in this zone we are getting decreasing return to scale. Now, coming back to your question here.
So, the calculation you have done at the top right, if you shift the screen a little lower. Yes, sir.
Yes.
So, like you did k naught equals to 5, so q equals to half 1 by 5 into k into L. So q is equal to L. And then you took that L is fixed, so it is a straight line.
L is not fixed, so because remember here what we have, here is its q, and here we have variable cost. If we move in this direction, q is increasing. So, q is increasing, what does it mean? That L has to increase. That is why cost is linearly increasing. So,
in that way, yeah.
So, this is a straight line passing through origin. Now, what we have here, we are talking about average variable cost. Okay. So, average variable cost is, one way to say is that you get a point on origin and get a point on the variable cost, and you draw a line. Again you will get the same line, slope is going to be same everywhere. So, that is why you get a straight line. But remember why it is decreasing here? Because in the beginning typically we have already discussed that in the beginning we get some kind of increasing return to scale, and later on we get the
increasing return to scale,
decreasing return to constant return, increasing first, then constant, and then decreasing return to scale. So, that is what is reflected here. Okay.
So, but here it is decreasing first.
So, the return to, notice this, we are talking about return to scale, that is increasing. That is what I am saying. there is inverse relation between the cost function and return to scale. If it is increasing return to scale, average cost will be decreasing.
Yes, sir. Then
Okay.
accordingly, it will fix.
So that is why I am saying here in this zone, what we are assuming, that we get increasing return to scale even in the short run. But you can very well say, how can you talk about increasing return to scale when you are not varying the capital? Okay. So what I mean to say is that rather than taking q is equal to f of k naught comma L as the production function, we take q is equal to f of L as the production function. You understand? Fine.